Okay, so we're going to keep going with the next presentation. So Micah Brown, right? Yes. Yeah. Okay. Getting all the names, we just met today, so so Micah is going to be our next presenter. He said to keep his title or intro real short, so just a shameless plug for their ISSA organization. So he is the vice president of the Greater Cincinnati ISSA chapter down in Cincinnati, obviously. So ISSA is the Information System Security Association, and he's going to talk about DLP Demystified. So I'm going to let you put these on, and then you got it the next hour, or as long as you need.
All right, do you guys have? Excellent. Am I coming through good for you, Adrian? Yes. Excellent. Well, once again, my name is Micah Brown. Thank you for going through and inviting me to be a part of today. All right. Glad to be here. So I formerly work with Munich Re as an IT security engineer too. For the past 4 years, I've been part of a DLP project, data loss prevention, as the lead engineer on that. In other fun facts, I'm a huge barbecue fanatic, so much so that last year, one of my official goals for my organization under personal development was learn to cook brisket like a Texan. I'm glad to say that I met and exceeded that goal in full. That being said, a shameless plug. We have a lot of good things going on in Cincinnati with local IT security groups. Matt, Barry, myself, we all run a group. We become great friends at these types of conferences and others. We run around and we have so much fun. So I urge you, find those groups, find those people that make your personal and professional life just a little bit better. I want to thank Barry and Matt and Gary for all of their help and support, and we'd love to have you at any one of our meetings if you're ever in the area. That being said, data loss prevention. Now, for those of you that are new to this, I'm sorry. This is a data-centric talk. However, misery loves company. That being said, what is DLP? Well, anymore, data loss prevention, it's not a monolithic stack of technology from one single organization. It is not meant to stop a sufficiently advanced adversary. It is not digital rights management. It is not end-user behavioral analytics, and it is not a silver bullet. What DLP is more and more, it's starting to become a feature in terms of what technology is putting in, or what various solutions are putting in to allow a business to control how data is stored, processed, and transmitted within their organization. In many ways, I view as data loss prevention as really more of a business tool that IT security might go through and might have ownership of from an administrative perspective, from an incident or event response perspective, but really is a function of the business in and of itself. So the golden triangle of data loss prevention is we want technology in order to to allow us to go through and to control how we store, how we process, and how we transmit data within our environment. That being said, in many DLP environments, this is done by different actors, by different technologies throughout. So the very first one is the DLP client. So this is a piece of software that sits on your client systems, and it interacts, and it's mainly watching and enforcing policies on how your end users are interacting with data. So this would be something to the effect of permitting or blocking access to external peripherals, looking at information that you're writing to an external peripheral and seeing if there's any sensitive information, and then making an allow an alert or a block decision, but it can also do things such as go through and enforce controls whenever someone takes a screen capture, go through and do inspection on emails that they're sending, on web posts that they're sending. The next one is DLP network. So I often go through and I tell people that DLP network, that's kind of like our traditional IDS systems, and we've gotten really good when it comes to IDS and IPS. And so a DLP network device will go through and ingest packets on a particular part of your network. Generally, you're going to use something like a SPAN port, a TAP, or if you've got a lot of good technology, maybe you might have a packet aggregator that's feeding these DLP networks. However, where an IDS IPS is looking at potential signs of attack, and the DLP network monitor is going to go through and it's going to look for potentially sensitive information traversing the network. The DLP repository scanner, so this is usually a server or a virtual appliance that you spin up, and it has a special software component that you point it at a repository, data repository. This could be a database server. This could be a traditional share, a NAS. This could be something such as a SharePoint, and it'll scan every file in that repository against your defined classifications, and then it'll either make an alert or take some sort of prescriptive action. We'll talk about that in a little bit later. DLP email, kind of simple. It's kind of like antivirus on our email. So you've got this either server or virtual appliance that'll partner with your mail server, and it'll go through and it'll perform DLP checks on every email sent and or received by your organization. I honestly think that there's value of scanning inbound emails, inbound traffic into your environment against DLP, because what I have found is that this has helped me discover actual events where we had sensitive information coming in suboptimal methods. And in order to go through and address that, we first have to be aware of that. Finally, we go through and we have we have DLP web. So this is, once again, usually a server or a virtual appliance that we go through, and it will form a bond with any proxy that you have to do DLP activities against any web traffic being sent and or received from your local environment. And finally, we have the DLP management console. And guys, this is one that we really need to pay attention to, because the DLP management console, this is kind of like the puppet master. It's the piece of the puzzle that goes through and coordinates all of the other parts of data loss prevention together. This is where we go through and we define what our policies are, what our data classifications are, as well as where we go through and we store our DLP incidents. And guys, the DLP incidents, keep in mind, what is DLP designed to do? It's defined areas where very sensitive information is going through your network in an unauthorized manner. And those usually manifest themselves as DLP incidents inside the DLP management console. So we need to go through and acknowledge that we're going to have very sensitive information, both primary information, things like HIPAA, GLBA, PCI, NPI in DLP incidents directly, but we're also going to have secondary information like where that data was flowing, where it was stored. And you better believe me, if I were to put on my black hat and I got access to the management console and I saw that there was a particular HR file that had personally identifiable information in this one folder, in this one file, what are the chances that other information in that folder would be likely as valuable? Chances are pretty good. So we need to make sure that we protect our DLP management console sufficiently to go through and make sure that we meet any rules, laws, or contractual obligations that we are under. So one of the challenges that I've had in implementing this is, why don't we just do everything on the client? It seems like today we have seen two big trends in the IT security environment. One is going through and focusing on the actual client, and the other is doing data first methodologies. And I define DLP as a data first methodology. And so there are some challenges with doing everything on the client. For example, we go through, or with our particular DLP solution, we go through and we have an option to do 12 data protection rules. We've only turned on one that adds significant value to us. The other ones just don't function in a way that actually add value. They actually add work to us, so they're a net negative. So we need to understand what DLP at any one of those points, what value is it going to go through and add to us. Secondly, when we go through and we turn on, especially the data protect rules, we're actually going through and every action that the user takes could potentially add a DLP scan, which is going to affect the compute cost of those computers in terms of CPU, memory, disk I/O, network I/O. So we need to go through and make sure that we keep our actual client configuration as lightweight as possible. That way we are not going through and we're introducing latency and causing problems for the rest of the business. Now guys, I love third-party software, and I love Chrome, and I love Firefox. The problem is that Google, for all the good that they are doing in our industry, they are very protective of Chrome in and of itself, so much that the very first day that my DLP vendor goes through and gets an update to Google Chrome is the same day that my end users are getting that update to Google Chrome. And one thing that actually happened to us is that Google significantly changed how Chrome worked, and overnight our Chrome became incompatible with our DLP client solution, and it resulted in crashes. Now guys, I was put in a position where I had to utter the words to our local desktop services. I understand that there is an incompatibility. However, we should be telling our users that the officially supported browser is Internet Explorer. Who wants to be that guy? Not me. But I did say that. And technically that is still true. And the problem is Google changed the underpinnings on how Chrome was working. So during that time, my DLP vendor had to go through and reverse engineer Google's Chrome new version so that they knew where to set their hooks so that they could provide DLP services. So in that case, what was our solution? Well, we're going to move web inspection off of the client and move it up onto a network level through something like a DLP network device that actually has worked out pretty good. You're going to get some applications that just don't work. And in fact, where we ran into this was really with our developers. So we had to go through and create what we call trusted application templates for several development tools. And basically what that says is, hey, DLP, don't mess with these processes. They're no good. And finally, we also have conflicts when it comes to other, what I refer to as more DLP enterprise. So depending on where you're intercepting with the DLP network monitors, you're going to go through and you could have overlap and duplication of incidents with things like your DLP web and your DLP email, just on what traffic your actual DLP monitors are going through and seeing. Once again, be mindful that the DLP management console is going to hold a lot of very sensitive information, and we need to have our additional controls to make sure that that is not abused. As well as many systems are now adding DLP light functionality to their environment. So we as administrators, we as IT security practitioners need to decide, do we want to use a single DLP policy stack to architecture to enforce all of our data loss prevention or do we want to write our DLP program in such a way that we can use multiple different DLP scan engines? And that's going to lead to some challenges. Initially, our organization went through and we were using one single vendor up and down the stack, which that has some pros, it has some cons. It means that as a plus, we go through and we have consistent classifications across all of our environments. As a con, we are actually choosing to limit our functionality to just that one vendor. And we'll talk about some of this, but now now we're in a situation where where we actually have 2 DLP environments, and we're looking to add 4 in total in about 18 months. So we'll talk about the trade-offs there as we talk a little bit later. So the number one thing that we need to do is to define our goals and to define it clearly. So I just got back from a trip to Munich, and one thing that was interesting is I was paying attention as I was in the airport, and I saw a poster for a data loss prevention product, and it showed a business person mid-flight looking like they were running to their office, and they had the typical taglines of that now more than ever, our data is one of our competitive advantages, and this company's DLP stops the bad guys from stealing your data. And put yourselves in our executive shoes. How many times a day do we hear about breaches and that they're a significant issue? We hear that all the time. So many records were lost. And so to an executive, if they hear a tool called data loss prevention, that's naturally going to go through and be very attractive to them, right? So what we need to do as IT and IT security, we need to shape and provide the true value of what can these tools do for us, because they can do a lot of good, but they're not a silver bullet. So during our project over 4 years, we had the project run many different ways. It started out that we had a program coordinator that ran it, that wanted to be a program coordinator half the time, and half the time wanted to be a project manager. We had an issue where the senior management started to get frustrated with the actual speed of the project, and so they started to make decisions that had adverse effects because they didn't understand the full ramifications of those decisions, until finally I stepped up and I took over the roles of both the actual lead engineer and the lead program manager. And what that did is that allowed me to control the actual narrative, to say definitively, this is what we can do, and to paint the consequences of those. And truly, that was one of the most effective ways to run it, because we were able to control the narrative to make sure that we were educating all business partners as to what the intent of DLP actually was. We need to be very clear and define exactly what functionality we're turning on. For example, Munich Re is a global company. So when we take a look at the global implications, I believe it is fair to say that the European Union has much more progressive data privacy rights than we do here in America. And that's manifested actually in our DLP regulation, where in the Americas, we have a rule that says when a person writes a file to a piece of portable media, we check it to see if there's any critical or any classified information, any sensitive information written in that file and or folder. And if there is, we allow the right, but we create a DLP incident on the back end. We're not allowed to roll that out anywhere else in the globe because of data privacy concerns. In terms of our rules, laws, and regulations, we see things like the California Consumer Privacy Act, and yeah, I think that might actually have some future splash damage for us. So we'll have to keep that keep that in play. We need to go through and we need to invite not just IT to the table, but inviting the various business units, inviting HR, inviting legal to the table, because each one of them, at the end of the day, are owners of their data. They are data stewards. We need to tell them this is the capabilities, this is what we can do for you, and work with them to make sure that any rules that we put out, any policies we publish through DLP actually adds value to the business. So, in our environment, there was what I refer to as the Great Potatoing event, and this was within the first year that we turned on the environment. Luckily, we only had a sample of about 15 computers, but these were all security users, up to the very height of IT security, as well all the way down to me and some of my colleagues. And because I made a single logic error in a data classification that was akin to leaving out one single parenthesis in a data classification, I introduced a memory leak that over a period of 35 minutes turned each and every one of our computers into a potato. So we need to be very, very careful when we're making any type of changes to our environment. So to help go through and to correct that, we set up a test environment with its own test classifications, with its own test rules. We set up a pilot group with its own pilot classifications, with its own pilot rules, and a production environment with its production classifications and production rules. As we grew and rolled that out, not just to the Americas, but globally, we had to go through and we had to create that same 3 policy architecture, each containing their own unique revisions of rules and its own unique revisions of classifications for our APAC and our EMEA locations. So now we have 9 different environments, each with different classifications, each with different rules. So every time you fragment a policy, you're adding complexity and support issues for yourself. However, you need to determine what the correct level of fragmentation is for you and your environment so that when you go through and when you do implement it, you are doing it in a manner in which adds as much value to the business and makes it so that you prevent events like the Great Potatoing. So, there was one decision when we were running the actual project from senior management on down. They were getting a little bit frustrated with the actual time it was taking to do our initial rollout. And they came to me and said, Micah, we need to go on this day. And so I said, I hear that. I do have some concerns about our availability to go through and to respond to DLP events, but give me 24 hours and I can quantify those for you. When it comes to DLP, we're putting ourselves at a very interesting decision. How are we treating DLP in our environment? Is it what I refer to as an active defense tool set in which we are going through and we are required to look at each and every alert? Or is it a historical sim where we're just keeping a record of what happened in our network? That way, if we ever need to go through and query, we've got those answers right there. If we were involved in a breach and it was found that we had alerts, but no one was looking at those alerts, is that a lack of due care or is that negligence? That's not something for Micah the engineer to decide. That's something that the business needs to decide and make sure that we build the environment so that we can go through and we can support it and we can be successful. So when they came to me and they said that we want to go live, I said, oh, all right, that's fine. You want to go live? I went through, I calculated how many incidents did the average user create a day? And that was 96. I then did the math and calculated that, what's the number? 4,235 were the number of DLP engineers that we would need to go through and respond to each of those incidents, assuming that we were only looking for incidents made during 8 to 5.
So the jobs are posted? Is that what you're saying? You're hiring?
We are actually hiring, but not that number. They said, this is unacceptable. What do we need to do? I said, it's quite simple. We need more time to go through and to tune the environment. And so they said, good, that's what we need to do. So the moral of this story is we need to go through and we need to present the challenges that we're facing to management in a term that they can understand. And that was as inflammatory as I was told as that number was, it did get the message across. And now, after we did many, many rounds of tuning, we're down to about 3 incidents a week per person. I'd assert that that's something that is much, much, much more manageable. My good friend Matt, who you just heard before, anytime somebody comes onto the DLP project, there are a couple videos that I give them. I give them this slide deck to read through. I give them Matt's 2017 Regex 101 talk from DerbyCon.
And he did present that at OISF meeting as well. Thank you, Matt.
Welcome.
And those are some critical on-ramps. But when I'm doing this tuning, we need to acknowledge that there is a risk in over-tuning. And what I mean by over-tuning is we tweak a rule so much so that actions on the environment that should have created an alert do no longer create an alert. I'd rather go through and create a ton false positives than actually introduce a true negative. So anytime that I'm doing tuning activity, I'm very conscious and I ask myself, if I were an end user, could I use this tuning to go through and to subvert the actions of DLP? And that I use that as a guiding rule. Now, if you ever work anytime with me, you will get immensely annoyed with how often I say that. But I truly believe there are no false positives, only poorly written rules. When I look at a DLP event, I do a couple things. First off, I go through and I try to strip human emotion out of it. I go through, I take a look at the actual event, I take a look at what the rule is, I take a look at what the actual data that was fed into that event were, and I ask myself, if I were following those logic commands, do I agree? And most of the time, I do. Anytime that I've seen a true false positive, it's been because of a bug. But if you think about it, how long have we been doing computer-based logic? We've been doing it for a lot of time, and we've gotten really good at creating these logic views. So my default assumption is there are no false positives, only poorly written rules. And I think there's a danger to labeling things as false positives that are really badly written rules. Why? Because we're going through and we are undermining the validity of our tools. We're saying that our tools are giving us bad information, that we cannot trust our tools, and we should not undermine that. Instead, what I did is I started to introduce validity and accuracy, where validity, did we get the result that we expected, and accuracy, asking, is the detection, is the alert mathematically correct? And what that small tweak does is it puts us in a default standpoint that we need to go through and we need to improve our tools, that we need to tweak our tools, our classifications, versus just saying that the tool is adding a bunch of noise. It's adding a bunch of false positives, a bunch of extra work. So I think that is actually a critical mind shift that I would suggest that you think about adopting, because it's actually promoted a lot more, how do I want to say this, a different attitude in where now my DLP team, instead of saying, oh, that's just a false positive, throw it away, saying, you know, this detection, it was suboptimal, but maybe we could tweak the rules in order to improve our algorithms. So, with that being said, traditional DLP policy is based on regular expressions, word dictionaries, and Boolean logic. And in truth, we're getting pretty good at that, but it does have some limitations. For example, in the United States of America, we have 50 different states that are each allowed to go through and to create their own driver's license any way or shape that they want to. And trust me, there are differences. I'll actually show you our secret sauce on how we define them. Likewise, many of our social media and large internet content providers go through and use a 15 to 16 digit or numeric code to reference content. What does that look like to a computer? It looks like a credit card, right? In fact, I've gone through and I took a sample of these types of alerts, and I even ran them through the lung check, and many of them came out as valid credit cards. Traditionally, or that leads me to believe that in and of itself, traditional data classification based on regular expression, text dictionaries, and Boolean logic is not enough, and we need to be able to go through and do better. Now, one thing I will urge you is whenever you go through and you create your own custom classifications, follow the primary rule of improv comedy. Always say yes and we'll get to an issue where I broke that rule and it really caused a lot of problems. And finally, proximity rules can be your friend. So this is where you're looking for condition A and condition B to be true within so many characters of yourself, whether it's 90, 100, 200, but just linking two contents to be close to each other, that is hugely powerful. So guys, right here is how I go through and I write our DLP rules. So over on the left hand here, I go through and I write what the classification name is. I give a quick description of what it is or of what it's looking for, followed by what type of rule. So you can see this is a proximity. Right here we're just looking for an advanced pattern. Right here is a dictionary plus an advanced pattern. And the truth is that when you see these rules, there's nothing magical about them. In fact, they're pretty easy to understand once I walk you through. So over here, you can see in terms of advanced patterns or regular expressions, we have each one of these individual blue entries is a different regular expression dictionary that we have. So we're looking for one of these regular expression dictionaries and something from a text dictionary that is less than 90 characters from each other and found at least once. In truth, I go through, and when I go through and I run, say, a scan, or I have an auditor, internal or external, ask me how DLP works, I give them this sheet and I walk through a couple of examples, because once you go through this, it's pretty easy to understand why these rules, why these alerts trigger, and it's pretty easy for the business or an auditor or someone from IT to understand how we are building our rules and how we can go through and improve them. One thing that I will go through and suggest to you is when we're going through and we are looking, you can see that I take a couple shortcuts. So at the start of every custom building block that I put in, I tag it with a short code. So CLT stands for client, then this is version 11, and DEF stands for default. So just by the short tag, I know whether it's part of our client environment or the enterprise environment. I know what revision that DLP rule was written under, and I know what specific environment, whether it's our test, pilot, or default. Likewise, at the end, I tag it with another code. So right here you see EXPR, right here you see TXT. EXPR stands for regular expression, TXT stands for text. So just by looking at the name, my DLP analysts can understand exactly what that part is, as well as where it is applied within our environment. So I found that to be invaluable, and I'd suggest that you take that simple hack with you. So the tyranny of the driver's license, I promised you this. Over here on our left, these are how we define our driver's license. You will find 26 different driver's licenses. By the way, I forgot to mention this. All these slides are out on my GitHub, free. Please feel free to beg, borrow, or steal. That being said, that's how we go through and we define driver's license. However, there was some challenges. Things like our incidents, our user IDs, our service desk tickets, our quality control tickets, our change tickets. Something as simple as year, day, month, this was day, month, year. Go through and we're matching our actual driver's license definition. So we had to go through and we had to exclude them. Remember when I told you that I broke the first rule of improv comedy? That's this story. So in the past, we had a concept of a driver's license just being a match on one of those regular expressions in that regular expression dictionary. And we started to go through, and as we tuned, even as we tuned out certain patterns, we were getting other things that were matching, things like telephone numbers, fax numbers. So what we did is we created a driver's license classification, and we created a not driver's license classification. In the not driver's license classification, we were still going through we're going through and we were looking for the exact same regular expression plus a text dictionary that would go through and indicate that what we defined was not a driver's license. So this would be things like phone, text, mobile, and that worked great if all I cared about was driver's license, but I'm an insurance company. I care about HIPAA, I care about PCI, I care about GLBA. And so what we found out was the way that the logic is when an incident went to be created, we would exempt it if it had a not driver's license classification, meaning that if an actual incident went through and had a PCI, a GLBA, plus a driver's license and a not driver's license classification, in my mind, Micah says that should have created an incident. However, the rules that I set forth would have exempted it. So instead, what we did is we switched that to a yes and. So our new driver's license goes through and we're looking for a regular expression dictionary plus a custom dictionary that indicates a positive driver's license match. So we're looking for things like a license, LIC number, LIC, VIN, driver's license, vehicle, things that we would expect to be found around a driver's license. And this simple tweak went through and took our driver's license classification from being our second most chatty to one of our most accurate overnight. So by doing small tweaks, you can have a huge wins. So I've really bashed traditional data classifications. What can we do to augment those, to make them better? Simple. We weaponize our users. And what I mean by that is we involve our users in going through and doing data classification for us. Many common Office-type applications allow you to create custom meta tag data and allow your users to simply apply those tags to the metadata of your document. And this is wonderful. It's on two fronts. Front number one, technically, these tags are in the headers of the document, in a place where anyone or any system that has access to that information can quickly read it. And reading that information is really fast. It's really easy for a DLP scan engine or any engine to read the header information of a document, and it's very accurate. Secondly, in an unintended consequence, is every time a user is interacting and saving a document, we pop up a little or message if they had not classified it and ask them, excuse me, would you mind telling us what classification you think that this document is? And then our little pop-up, it has the data classifications as spelled out, plus a little description of what that means. And it's really simple for a user to read the description and to self-decide what level that is. Now that goes through and has, A, we're using our users. B, we're also asking our users to help participate, to take that little second to ask themselves, if this were to get out or to leave unauthorized, what would the worst impact be? And that statistically has gone through and improved our users in becoming better data stewards. There's a lot of really interesting research on something that's involving users in that type of data classification and how that has sweeping changes within an organization and how they manage data. And I can tell you, it's true. Anecdotally, I now have users coming up to me and saying, hey, Micah, we're looking to do this with our data. Currently, we go through and we send it this way. Is there a better way that we should be thinking about it? So just involving your users and having that constant reminder that, hey, this data, it's really sensitive to our organization. This really, as an insurance company, our data is our competitive advantage. It's how we build our insurance policies. It's how we build our classification. It really is important, and it's important to remind our users that that is important. So now we're going to go through and we're going to play a game. So how many people have read Frank Herbert's Dune? For me, it's one of my favorite sci-fi series. The first 4 books are great. After that, they get a little bit weird. So with that, Paul Atreides, our emperor, has asked us to create a data classification for him and our empire. So we are going to be up here, based in Arrakis, basically the center of the universe. After all, the spice must flow. When it comes to Chapter House and Caladan, we are allies, represented by the green arrows. However, we are enemies with Corran and Gidi Prime. So the very first thing that we need to do in order to create a DLP policy is we have to have knowledge of ourselves, or as I like to say, intimacy. Into me I see, TM. So we're going to go through and we're going to create a data classification. So in this case, we're going to have 5 different types of data classification. We have A1 is public, free to be shared or to and from anyone. A2 is proprietary, and it's used it's only to be used within Arrakis' government. A3 is diplomatic, meaning that it can be shared with anyone and everyone. However, we have to protect the integrity. We have to apply a digital signature to it. A4 is internal. It cannot be transmitted to the Arrakis government or outside the Arrakis government. And A5 is top secret. So once we have our data classification, the very first thing that we have to do is we go back to our data flow map and we apply what the rules actually look like. This is a critical point anytime I do any type of DLP work, is I go through and I make a nice map that visualizes it to the business so that they can understand exactly what we are doing, exactly what we are trying to do. And this is something that has had great success. So I highly, highly, highly recommend that you go through and use that. From there, I go through and for each classification, I break it down into documentation like this. This is what I, as an engineer or the analyst, would use to translate that pretty map into the actual documentation that we would then go through and put into our system. So, how do we go through and how do we bypass it? How do we, if we are a little bit more offensive in mind, how do we detect and bypass DLP? Well, let's all put on our offensive hats. What is the very first thing that you would do when you go through and you get a shell on a system?
Celebrate.
What's the second thing you do?
Who am I?
Who am I? You want to see who you are. You want to see what you're running. So all of these DLP tools that us defenders, us blue hats and white hats are running, they're all documented. We can just dump a process list and we can see, are there any processes that would indicate that we're under either AV or DLP? In fact, we do this all the time for antivirus. And trust me, there are bypasses for every DLP. You could crash it, you could hide it, you could pause it, you could suspend it, you could stomp all over it. And if you don't have adequate logging on your processes, how would you even know? So the second thing that we need to acknowledge is we understand that we can overcome the actual client pretty easily, but what about this stuff on the network? Well, unfortunately, the way I describe DLP is it is based on regular expression and text dictionaries. Even the most basic of encryption or data obfuscation will go through and convert something that should trigger a DLP event into something that would not. This is where we're going through and we're requiring to make sure that you understand that as good as DLP claims to be, it does have some weaknesses, and cryptography is one of those. Also, we need to go, so if cryptography is an issue, why don't we just MTM ourselves so that we can see inside of any crypto traveling between a network segment? There have been issues where I have been responding to an event that happened, and it was found out that a company that did introduce that type of man-in-the-middle inspection had not configured that optimally, and as such, put themselves in a situation where they downgraded the crypto suites that were actually running, and that had a very bad event. So just keep in mind that there is a cost if you do go through and you do insert yourself in a man-in-the-middle type of situation. Make sure that you're using the correct crypto ciphers on both the receiving and the sending side, and that you have a control to check that regularly. And on top of that, DLP can provide a lot of really interesting information, and a lot of that is really, really sensitive. So as an attacker, if you know that you're in a DLP-enabled environment, I would want to go through and I'd want to try to figure out where that DLP information store is, because I'm going to get a lot of really sensitive information that's going to go through and tell me where other potentially sensitive information is. With that, that's the end of my presentations. Any questions?
Do you have any tips on finding where the DLP store is?
So that depends on the actual environment, or the actual DLP tool is. Different tools place it in different areas. So in the DLP tools that I use, there is a little icon in the lower right-hand corner. I can simply right-click on that icon and I can click About, and it'll tell me exactly where that DLP management console is.
Where would it be?
Just like your AV or any other controls, it usually says, hey, here's my server.
Okay, cool.
Any other questions?
Talk a little bit about the client application.
Mm-hmm.
Can you speak a little bit more to the server side and how some of that interacts with the client, and things to protect some of the communications to where it's not exposing any additional vulnerabilities?
All right, let me chew that over for a second. In the case of that, it's going to depend on how each individual solution is architected. In the case of the one that we use, the management console sits on a server inside our traditional environment. In order to go through and to upload an incident or get updates, the client must be connected to that, and there's a default check-in of randomized every hour. So it could be at 20 minutes, it could be at 30 minutes, it could be at 40 minutes, it could be at 57 minutes, but within each hour, it will check in at least once. All of the communications from the management console to the end client system are encrypted with TLS 1.2. However, if I am a sufficiently advanced adversary and I have root on the local system, I'm of course going to be able to see everything that's going on inside once that hits the end client user.
Okay.
Any other questions?
The server, is that something that you run in a VM type of, or is it something that's a physical, or it doesn't matter?
So usually it depends on which DLP solution you're using. In our case, the network monitor can be physical or virtual. With respect to the actual or with respect to the virtual, there is some concerns about making sure that your hypervisor can support turning those ports built into the hardware into promiscuous mode. In terms of the DLP repository scanner, that's just a piece of software that you can add to a physical or virtual in our or with our tool. However, I have seen some tools where this is its own standalone VM. The email, that's another piece of software that either you can install on a either physical or virtual server, or they do have a virtual appliance that's running a hardened Linux. The same thing that I said for email is true with web. And the DLP management console that we use, that is just that's just an application that you can load onto a virtual machine or a physical server, or you could choose the vendor's cloud version of that. Oh, I'm sorry.
Of course, I heard you talk already. But I was going to ask you this question a couple of previous times. Well, I want to ask. So, you just, in your talk, you admit that the DLP by itself is a target, a potential target, right?
DLP is very good for what it's designed to do. However, we need to be very careful to go through and to explicitly help guide the business to understand what DLP can do and what it cannot do to our environments. In my mind, DLP is not meant to stop a sufficiently advanced adversary.
Right. But as far as being a target, just like you suggested, because it's potential attacker or adversary can learn a lot if they compromise DLP, right?
They can attempt to bypass it, yes.
Or attempt to bypass. So what you see is the biggest weaknesses or weakness of DLP system, except of course positive.
The biggest weakness of DLP, in my opinion, is the name data loss prevention, because it sets an unrealistic expectation. I'll throw this out there. So within my organization, after 4 years, we have deployed 3 rules. The first rule is for all client systems, when somebody plugs in a piece of portable media, we go through and we deny access to that portable media unless the user is a member of an Active Directory group. That piece of portable media has had a trusted device type defined for it, something like an A or like a little extension that you throw on to sling your presentation up to a projector or up to a TV, or it is a trusted machine type such as a kiosk machine. The second rule that we have is for any type of plug-and-play peripheral, where we go through and we block access unless one of those 3 exceptions is made. And the third rule, which is only applied to the Americas, is the Data Protect Portable Media rule, where if somebody does have access to portable media, we go through and any file or data that they write to that piece of portable media, we do a DLP scan against it. And if there is a match against one of our classifications, we create an incident on the back end, but we allow that action to take place. Now, keep in mind, when it comes to that right, we do have additional controls such as portable media encryption on top of DLP. It's a separate control, but I would argue complementary as well.
You talked about the performance hit that you get on the clients, and then I'm assuming there's a performance hit on your network based on traffic. I know you talked about how originally you set up the network and you were getting a lot of false positives as you had initially. Well,
no, they weren't false positives.
I finished. So, and then you had fine-tuned your rules, right? So, initially, did you have any kind of measurement of performance hits prior to your fine-tuning to after, and what your network traffic would load, and what your now that you've fine-tuned it, what your network load looks like with a DLP
So I want to answer that in a couple different ways. So in terms of the actual DLP network, we have not done any monitoring. Basically what that'll do, kind of like a backup job, it reaches out into the repository, grabs a copy, brings it over, runs a scan, and then deletes the copy of it. The DLP email, that is done in our cloud environment, so that is all within the email. We don't have any metrics around that. The DLP web, we're working on turning that up now. We haven't done anything around that. With the DLP monitor, what is critical to understand with that one, we're feeding it currently off of a tap, so the traffic that is seen there is a shadow copy of the data, so no network impact on that. But where you hit home is there is now a trend to blame DLP for any client performance issue. So to go through and to do that, we have an agent on a couple of our IT security machines that will go through and it'll sample several times a second the CPU, the memory, the network I/O, the disk I/O, all of those good stats per process. And we can go through and we can query that, and we can take a look and say this is the true cost of DLP on that client system. And that's gone through and been very, very beneficial in going through and vindicating in many situations the actual true cost of the DLP client on those machines. But keep in mind, both in the number of classifications as well as the number of rules that I have active on my DLP clients, it's very, very small, and that's by design because we're trying to offload as much of those more enterprise type tasks up higher in the stack to ensure that our clients can run at full speed.
Right. So have you seen an increase in client to the DLP network as far as an increase in traffic flow?
Not in traffic flow, but...
You're not taking an overhead performance and extra network traffic coming out of the client with its reporting criteria?
Not really, because the average client is only going through and creating 3 DLP incidents a day in the Americas. And those are the data protect, which are a little bit heavier because the device control incidents are just, hey, we blocked this device, or hey, we allowed this device. Whereas when we're talking about the data protect, that's where we're actually going through and adding a copy of that evidence file, or the file that triggered the event.
As opposed to your initial 100 a day.
Well, the initial 100 a day, and that was because our rules were horrible. And if I would say something on tuning, it's really easy the first pass that you take at tuning to get the first 80% knocked off. It's a little bit harder to do the next round, and even harder to do the following one. You have to get very creative, and unfortunately, one of the problems that we struggle with is that we're using a different DLP scan engine in our email than we are for the rest of the network, and the different classifications within the network or within the email versus the rest of the environment means that when I have a DLP analyst looking at our email, they're looking at different classification, different regular expressions, different text dictionaries, different rules of logic, which is similar but not the same. And I see that the fragmentation based on classifications is a very big risk. I think if we could, for some of the bigger MPI, some of the HIPAA, PCI, GLBA, have some sort of open source definitions that all vendors could kind of agree to, I think that'd be a huge win. However, the DLP manufacturers are incentivized to go through and to not allow that type of collaboration to go through and exist.
I have a non-DLP question for you, Micah. I got a question though, because when we went back about 10, maybe 20 slides with Neo, I thought about something, and this has nothing to do with DLP, but it does reflect some of the things that you were saying. There are no bad rules. I mean, there are no false positives, only bad rules. One thing that came to mind is there are news articles and reports about self-driving cars. And one of the common issues they experience are that with the driving algorithms are found when human drivers don't stick to the rules of driving. And so those self-driving cars have issues with people not sticking to the rules. So I was thinking, could we use this concept that you were talking about, theoretically, because none of us are self-driving car engineers, could we use this theoretically to help these machines flow a little bit better in chaotic traffic?
So the way that I will answer this is I have started to be very obnoxious with that philosophy and inject that anytime the dreaded FP word is uttered in my presence. There are no false positives, only poorly written rules.
You talk about like a fuzzy logic approach to where around 3 o'clock in about 5 minutes type of, well, I think I'm doing 55, but you're actually doing 70,
Self-driving cars usually have that's been the biggest problem of their thing. When people don't follow rules, those things freak out. And so I'm saying, well,
And not just people on the road driving cars, but also people that are not in cars, bikes, motorcycles, pedestrians.
Yeah. So could that conceptual process be used in those algorithms to try to help those cars think a little bit clearer, theoretically?
I am not a data scientist.
That's when you get into fuzzy logic algorithms. That's a whole other thing. We can talk a couple hours on that later. All right. Anything else? Any other questions? Hey.
Thank you very much for this opportunity.